Okay, so hopefully you've done all of these. Now we're going to look at these problems. A population of fruit flies is growing at a constant rate of 6% per hour. So it's growing. So we would do 1 plus 0.06. The population starts at 28 flies. Find a formula that models the population. Don't even read the rest. We're going to do y equals 28, 1 plus 0.06 to the x. Now, we have to use the letters they give us. Time is always the x. So that means the other letter goes here. Population, 28 times, I'm just going to put 1.06. It's a little less to write. So there's our formula. Now they want to know the value P of 24. Like we learned way back in the beginning of the year, if the number's in parentheses, that goes in our X spot or our T spot. P equals 28. So this means after 24 hours, how many fruit flies are there? Remember, it started at 28. 28, 6% per hour. You could do 1 plus 0.06. Exponent 24. 113 flies. It's kind of gross. Ew. Okay, number 7. This is an old Regents type of question. Oh, no, we have to skip this one. You know why? Sorry, folks. There's no formula that copied over. So we'll skip that one. Number 8. Which of the following equations could model an exponential quantity that begins at a level of 16 and decreases at a constant rate of 8% per hour? Don't even look at these yet. I'm going to scribble that or erase that in a sec. We have our formula. Starting number begins at 16. And it decreases, so we're going to minus, move that decimal over, 0.08 to the x. Now, we've got that done. If you look back over here, nothing matches. It doesn't mean pick that one, because that means 1 plus 0.08. So let's put it in our calculator. I'm going to just type this in and see what I get. 1 minus 0.08 is 0.92. So I could also write this problem as y equals 16.92 to the x, which is that one. Tricky, right? Now, if you know what you're looking at for these equations, this problem is pretty simple, at least A and B. So remember, this is our starting number. This is 1 plus our percent. Now I'll read the problem. An oil spill is spreading such that its area is given by that exponential function. A of t equals 250 times 1.5 to the t, where A is the area in square feet and t is the time that has elapsed. Now part A says, how large was it initially? That means the start. That number right there. All you have to write is 250, but if you want to write 250 square feet, that's cool too. Now part B, by what percent is the oil spill increasing? Remember, this is our percent. Our percent is in 0.15. To turn it into a percent, move it over, 15%. Now, same idea for number 10. This one's a little bit trickier. The amount A in grams of radioactive material that is decaying can be modeled by this equation. D is the number of days since it started its decay, so it's going down. Part A says by what percent is the material decaying? It's a 0.88. This is tricky now because remember our formula is 1 plus percent. We can also change this to 1 minus whatever that percent is. And we get 0.88. Look, I'm turning this into an equation now. What number gives you 0.88? You might be able to do it in your head. What I'm going to do, since I can't talk to you right now, it's on video, I'm going to move this percent symbol over, and I'm going to minus this 0.88, move it over here. So I end up with 1 minus 0.88. 1 minus 0.88 is 0.12. If you can do that in your head, that's totally fine. If you are stuck on that, let me know and we can go over it in a little bit more detail. Hey, look, it's lunchtime. Perfect timing, guys. Make sure if you're remote that you submit a copy of your work on these pages. Take care, guys.